As part of our Hamburg Mix Design series, we talked to 6 companies about their Hamburg test equipment. Here is our interview with Andrew Cooper from Cox Sons.
Good morning, Andrew. Thanks for joining us. Can you tell us a little bit about your company?
Yes, there are in fact 2 companies, Cox Sons and Cooper Research Technology. Cooper Research Technology was started by my father back in early 1990s, and he worked at the University of Nottingham and was involved in designing machines. He was the chief technical officer in the area of asphalt research. And when I was young and I was at school, he was bringing back computers when other people in my school had never seen computers. We certainly didn't have any computers at school. And he became interested in using computers to acquire data from machines which previously the technicians had to take down manually or were on the old card readers. So he was hooking up computers to acquire information. Then he switched to actually being able to send out signals. So not only could he acquire information, he could also tell machines what to do. And whilst he was at the University of Nottingham, his professor, Stephen Brown, and he developed this piece of equipment called the Nottingham Asphalt Tester. And in the early 1990s, he left the University of Nottingham because this machine became popular and adopted all around the world. He then went on to design other pieces of equipment like wheel trackers, roller compactors, and gyratory compactors. Now, unbeknown to us at that period of time, but across the Atlantic in Northern California, a fellow called Cox Sons was doing very similar things, and he was working at Caltrans. He left Caltrans to start his company called Cox Sons, and he was developing pieces of equipment to meet the requirements of the VEAM test method. And he was computerizing and automating machines which had formerly been mainly manually operated. And Cox and Cooper had these twin paths, Cooper working out in Europe, in other parts of the world, and Cox working on the machines in the US. In 2012, Cooper acquired Cox and Sons, and these 2 companies joined up. And at that point in time, we saw that there were a lot of synergies. And in fact, the professor that James Cox worked with was Carl Money-Smith. The professor my father worked with was Stephen Brown. And these 2 were very, very good friends. So there's a huge link with the companies in their approach to design, to approach to research. And that is how the 2 companies sort of developed through their existence and came to be working together. And now I work partly for Cox and Sons, partly for Cooper Research Technology. And I switch my time between the States, Europe, and other parts of the world.
Andrew, can you tell us about your Hamburg wheel tracking testing machine?
Yes. Well, Cooper first started developing wheel trackers, dry wheel trackers, back in the early 1990s. And one that I designed is still being used, at that time, is still being used at the University of Nottingham. We designed our first wet wheel tracker, known as the Hamburg wheel tracker, in the mid-90s. And that actually went to the Utah Department of Transport and was used there. But there wasn't much call for these machines outside of a few researchers at the time, because wheel tracking wasn't being used in the States that much. In other countries, there were dry wheel trackers, or in France, they had another type of a larger wheel tracker. So it wasn't until we joined up with Cox that we looked again at this piece of equipment, and we worked together. And Caltrans also needed a Hamburg wheel tracker, and Caltrans had some very specific requirements which led to the machine being what it is today. They wanted the machine to be made in 300 series stainless steel. They wanted the machine to last for 15 years as a minimum. They wanted a safety cage around it to protect the user. They wanted automatic arm lifts. And they were very interested at that time in the analysis of the results, because they wanted it to be used for specification. And the creep slope, the stripping slope, and the stripping inception point, all, if people actually draw a line on the graph, then it's open to interpretation, and the contractors may want to push it a certain a certain way. So we developed this machine, and I actually think the machine will last for a lot longer than 15 years, probably that they'll all outlast my working life. And that is how we got to the machine we have today. We've made some slight modifications to it, which I might touch on later. We've removed the mast and the winch. We have added electro actuators. We've moved away from pneumatics, and we've doubled the capacity of the heaters. But ostensibly, that's what it is. And our machine, basically, if in all the machines that were there, we would say that it was the quality, probably the more expensive end of the market, but looked as a full life costing, we would say it was the most competitive machine.
So Andrew, can you tell us about some of the safety features of your Hamburg wheel tracker?
Sure. Caltrans were very stringent in terms of wanting guarding, stainless steel guarding through which they could see. It's interlocked, so the wheel can never move whilst the guarding is open. The software won't allow it to move. It's impossible. At the outset of producing the machine, we had a winch which would enable the user to lift the arms up and hold them out of the way. So you could lift the arms up as well and hold them in an locked position. We didn't like this, and now we've moved away from it. We've moved away from the pneumatic actuators that hold the wheels up as well. And we've moved to electromechanical actuators, which fail safe in all conditions. So you don't have to worry about pneumatics, and pneumatics are something that a lot of people don't like nowadays. And also, should the power cut at any point in time, the wheels and the arms will stay exactly where they are. And the user can just pull the molds in and out without having to lift or make any manual lifts on the arm themselves.
Okay, Andrew, does your machine comply with the current AASHTO T324, and does it comply with any other standards that are noteworthy?
I would say that the Cox machine meets every aspect of AASHTO T324 2019. I would say that it meets every state standard for immersion wheel tracking or Hamburg wheel tracking. I also believe it meets every international standard in terms of Hamburg wheel tracking, wet wheel tracking. And I would go further than that and suggest that it is likely to meet any future standard that is published for Hamburg wheel tracking. In 2015, there was an NCHRP report, which was authored by Louis Mohammed and his team, in which they assessed a variety of Hamburg wheel trackers and looked at how they met the 324 standard at that point in time. The Cox Sons machine came out top or equal top in pretty much every area that was assessed at that time. And some of those are very important areas. For example, there is something which is included in the 2019 standard, which is the root mean square error on sinusoidal motion. And sinusoidal motion is how that wheel moves backwards and forwards, and it determines where the wheel is at any point in time on the samples. Some machines, some of the older machines and some of the current machines still use a crank arm to drive the wheels backwards and forwards. And the crank arm does not produce sinusoidal motion, and it gets better or worse depending on how long the crank arm is. What this means is that the wheel of such a machine will spend more time on one side of the specimen than it will on the other, which over the course of 20,000 passes can result in, will result in uneven deformation. So the Cox and Sons machine and the APA Junior, because they use a system called a Scotch yoke, scored very, very highly on this, and the machines that used the crank arm scored very, very poorly. The Cox machine was the highest scoring machine, or with the lowest error, in terms of measuring the rut depth at the points required. It was the best of all the machines that were assessed at that point in time. And measuring the rut depth is the key along with ensuring the temperature is correct and the speed is correct, is one of the key parameters in terms of any Hamburg wheel tracker. It was also the best performing machine in that report in terms of analyzing data for the creep, stripping, and stripping inflection point. And I would say that it was better than the university methods of assessing the creep, stripping, and stripping inflection point. It was better than the other methods, the non-commercial methods that were put forward as well. As mentioned earlier on, we double our heating capacity after that to accelerate the time it takes to reach the test temperature. And the other, another key point, and the one which allows me to say I believe the machine is future-proof, is the fact that we take 230 data points in each pass. The wheel moves for 230 millimeters as it makes a pass. We take a reading every one of those millimeters, which if AASHTO or any state decides that they want to take measurements in different areas, they will be able to, we will easily be able to modify what our machine does, and it will not need a change of anything mechanical. It's already in the software. I could do that in 5 minutes. I could write any sort of routine to acquire data, take the mean, the deepest of any combination of points measured across that surface. So I think that allows us to be fairly confident in terms of saying to a potential user that we believe this is a machine that will not fall foul of any changes in the specifications going forward in the foreseeable future.
If I were to purchase a Hamburg wheel tracking device from your company, what do you recommend for calibration and maintenance of that machine?
Well, I would expect anyone with a machine like a Hamburg wheel tracker to calibrate that machine on an annual basis. In most cases, you would use a third-party person to come in and calibrate that. But we do ourselves go and calibrate some machines, and I will do that myself sometimes because I enjoy talking to the customer and receiving feedback, which we can then put into modifications of the design in the future. There is not a method to measure this, but was measured in the NCHRP report in 2015, was the sinusoidal performance of the arm. And so there is a requirement, but there isn't a method to actually measure it. And we are using a laser triangulation device, which would allow the user of any model of Hamburg wheel tracker to determine that their machine, the wheel on the machine is moving backwards and forwards sinusoidally according within the specification required by the standard. So most people who have a Hamburg wheel tracker will calibrate the Hamburg wheel tracker on an annual basis, and there will be a local calibrator generally who is able to do that and produce a certificate which is acceptable so that they can use the machine for specification purposes. However, there is some interest nowadays in having the ability to check the machine on a more frequent basis, because 12 months is a long time to go. If an issue should occur the day after calibration, then you would have a long time in which you were producing incorrect results. The AASHTO 2019 standard is really very useful now in terms of the advice it gives for people wishing to calibrate aspects of their machine. And it talks about temperature, it talks about the dimensional aspects of the wheel, the load, the speed, and a couple of other aspects which have been introduced more recently. And these are a way of homogenizing the machines out there. One is the use of the aluminum profile, which is drawn in the standard and can be produced by anybody or can be purchased from a company such as Cox. And if any wheel tracker is rolled along this aluminum profile, the data it produces, with a little correction for the fact that you're measuring through the wheel, should fit the curve exactly. And if it does not fit that curve and does not fit within the margin of error given in the standard, then something has to be done about that machine, and it is out of calibration effectively. The other area which is mentioned in the standard now is sinusoidal motion of the wheel moving backwards and forwards. And as mentioned before, the reason for sinusoidal motion and the importance put on it nowadays is the fact that in some earlier reports and assessments of Hamburg wheel trackers, it was discovered that some machines do not produce sinusoidal motion, and consequently the wheel spends more time generally on the back puck than the front puck, which can lead to biased deformations, which means that not all machines produce the same data. In order to measure sinusoidal behavior of the wheel, we have developed a triangulated laser device which measures the wheel speed as it comes backwards and forwards in relation to the displacement. And this enables anybody with a Hamburg wheel tracker to measure the performance of their wheel tracker and to be assured that it is performing within the limits set in the standard. We can perform this task ourselves and to go on site and to undertake this ourselves, or we can sell these devices to people wishing to assess their machines on a regular basis themselves.
Andrew, what does your company offer for service and support?
Well, we're based, although my accent would suggest otherwise, James Cox Sons is based in Colfax, Northern California, and we have technicians who will fly to various parts of the US to service and calibrate machines for customers that require or ask that we do so. Additionally, we work with a lot of calibration companies throughout the US, AdTech, CalCert, and in Texas as well. And they will go and perform calibrations of our machine and speak directly with our technicians should they have questions relating to our machines. So we cover the country using our own guys and using accredited calibrators throughout the US.
So Andrew, if I purchase one of your machines, what's required for me to prepare for that installation at my facility?
You would need a 220 volt, 25 amp supply, electrical supply. You will need water in and water out. So I would recommend a drain close by the machine to drain water from, which is always attached to the machine is always attached to. Water, sometimes people like to put hot water in. So generally people think in a lab of putting cold water into a Hamburg. But some people have started putting hot water in, particularly in California, where the requirements for getting to temperature are more onerous than in some other states. So this is something, in fact, a lot of people in California now look at using a water heater to supply water at the test temperature rather than cold water. We used to use air and we used to use a winch, but neither of these do we use on the latest machines. So you do not require an air supply to the machine at all. And apart from a connection to connect to a PC, that is everything you need to the machine in terms of supply and output.
All right, Andrew. Last question. In your opinion, what's next for the Hamburg wheel tracking test and other running index tests?
I can see things moving along the lines of the cracking tests, which now are the other part of balanced mix design, where we have quite simple machines that have been in laboratories for a long time. The compression testing machines, which are now used for ideal CT, for iFit, and other SCB and cracking tests. And they have been sort of enhanced by using fracture mechanic calculations, the The compliance in the machines has been addressed a little bit. The speed has been addressed and tightened up. And taking these machines that were, and these tests that were very basic, but just using, just with a few tweaks, have derived more information from them. And the Hamburg wheel tracker, because it's an empirical test and it's performance related rather than anything fundamental, has always seemed to languish behind other tests, such as flow number, which ostensibly outputs something very similar. And the interpretation of the curves has been investigated to a much greater degree. So I think there's the potential with Hamburg wheel trackers to get more from the data than has been the case in the past. Currently, the mean of the 5 central measurement locations is used in the AASHTO method. So if you look at the picture on the screen, you are taking the 5 central X's or crosses on those 2 pucks and looking at them and taking the mean of them for the AASHTO result. Those 2 pucks are pushed together along the line, which means that you have no aggregate interlock there. If the person doing the sawing or the sawing is not a great saw, you have a void there as well, which material could flow into when you start to run the wheel backwards and forwards. It is really a very poor place to take the measurements. The reasons I've drawn the 100mm circle within the 150mm circle is that if these were dynamic modulus pucks, you would extract the central portion of the puck with a core drill, because people know that the outside is where you have poor voids because of the boundary conditions or the boundary effect of the mold. So it's a very poor place to actually be taking those measurements. We now have the ability to measure the deformation in the center of the puck, because we can measure every single point along that surface. And not just us, but I imagine all the Hamburg manufacturers can measure the points all the way across the surface which is tracked. And if you were to start again and you were to think to yourself, where would be the best place to take these deformation measurements? You would instinctively look in the center of the core. So the furthest away from the boundaries, they have the best material in, the best compacted material. And not only that, but you have, if you do your test at the moment, you take the combination of 2 pucks together and say this is one side, the result from one side, and the combination of another 2 pucks together and say this is the other side. If there's too much of a gap between the deformation and those 2 results, you have to discard the results, because you do not know which one of them is the one that has performed badly, so you can't retain a result. If instead you looked at all 4 of those pucks as individual pucks, and you saw that one of them was the outlier, one of them had deformed more or one of them deformed less, if you had aggregate interlock on one and pieces of aggregate sitting on top of one another, and this didn't allow the puck to deform, for example, you could extract that and you still have 3 results from which you can take the mean, and I think it's a much better way to analyze the data.
Thank you to Andrew for representing James Cox Sons. If you'd like to learn more about James Cox Sons, visit their website linked below. To learn more about LASTRADA, the world's leading construction materials testing software, visit our contact page to speak with one of our engineers.